When you put it on, it completes the cycle once you start it. Oh, yeah. So it's like that's why it's like turning. Mm-hmm. We need more fish show. You think you could get the dish soap when you make the water? Do you need to get more dish soap?
Today is October 12th. Hello, guys. How are you? All right.
Hello.
Hello, hello.
Hi.
Oh my gosh, guys. All of your cameras are off. Come on. Some of you guys have to turn it on. Thank you, Samantha. Thank you, Mara. It's just so lonely, you know? It's like talking to a black screen. Do you guys know what that feels like? I do. It's like this whole semester. Although, I think I've been okay usually. You guys usually always put your camera on. A few in each section, so it's not bad. All right. Start with attendance. Tangwei, Alexis, sorry.
Here.
Joy. I do see you on the screen. Good. Jenny.
Yeah.
Samantha.
Did you just call my name?
Here.
I just called, well, I have everybody so far. I have Alexis, Joy, Jenny, and Samantha. So that's good. Emma.
I'm here.
Yep. Apurva. No? Okay, I'll come back to that. Gianna.
I'm here.
Great. Morgan. Naja.
I'm here.
Great. Christina.
I'm here.
Is here. Steffi.
I am here.
See Steffi. Amanda. Jenny has thumbs up, but Amanda is not here. James Lynn.
I'm here.
Great. Carrie.
Since I talked.
Here.
Savannah.
Here.
Mara. I think I see Mara. Yeah. Emily.
Here.
Liam.
Here.
Keely. Oh, I see you. Paulina.
I'm here.
Ashley.
Here.
Deidre.
Here.
Mhm. Laura,
Here.
Abby? No Abby? Okay. So last call. I've not heard from Abby. Amanda? No Amanda. Morgan? And then Apurva. No? Is it the rain? Could that be it? I know, I hate rainy days. Some people like the rain. It's too cold. I went to get coffee and I was like, nope, nope. And then I went back inside. Okay, let's see. Okay, so we started a new topic.
Sorry, Apurva just asked if we could hear her. I don't think we can hear her, but
Okay, but I know you're here, Apurva, so you're marked, of course, not absent. But yeah, maybe audio's not working. Okay, yes, I have the chat open now. Good, good, good. Always let me know. Good, good, good. Help out your friends. Gotta make some friends, right, guys? So lonely times. Okay. Oh gosh, guys, election is like a few weeks away. Oh my God. Okay, well, till this country is still functioning, let's continue with our stats concepts. Okay, so we have been introduced to a new topic, standard normal curve, okay? So instead of starting with a review like we usually do, I am going to actually, I'm gonna show you a video that is gonna actually kind of do a little bit of review up to the point we have, like very, very briefly. And then we're gonna actually learn a new topic first. Or kind of like, we will learn a new topic first, and then we will kind of do the review. It's just like a little bit of a reverse kind of thing going on, but it'll make sense in a second. Okay, so let me start with sharing my screen so that we can start with. So this is a nice, and I'm gonna stop the video when kind of like the brief summary is done, and then I'll let you know when we're learning the new concept. So we're going to learn a new concept, and then we're going to solve a lot of problems today together as a class to get used to the standard normal curve questions, left tail, right tail, area in between that we did last week. And then this new rule that we're going to do in relation to area under the curve. Okay, so we're going to just mostly do problems today with in relation to the area underneath the curve and this new concept. Okay, so let me start with sharing my screen. And I'll have, oh, that's right. I don't have like 2 screens today, but that's okay. All right, here we go.
In this video, we'll be learning about the normal distribution and the 6895-99.7 rule. When we talk about normal distributions, we refer to data we get from a population or sample. So before we actually talk about the normal distribution, we need to first distinguish the difference between a parameter and a statistic. A parameter is a number that describes the data from a population, whereas a statistic is a number that describes the data from a sample. Examples of parameters and statistics are the mean and standard deviation. But because of the definitions we just talked about, we have to be very careful with what symbols we use to represent these numbers. When we are dealing with a sample, we use the symbol x bar to represent the sample mean, and we use the letter s to represent the sample standard deviation. These are statistics. When we are dealing with a population, we use the Greek letter mu to represent the population mean, and we use the Greek letter sigma to represent the population standard deviation. These are parameters. The population parameters mu and sigma are very important when we talk about normally distributed populations. So what is a normal distribution anyways? A normal distribution is a special type of density curve that is bell-shaped. For this reason, the normal distribution is sometimes called the bell curve or the normal curve. The normal distribution describes the tendency for data to cluster around a central value. In fact, this central value is the population mean mu, which is always located in the middle of the curve. So for any normal distribution, we can say that some data points will fall below the mean, other data points will fall above the mean, but most of the data values are located near the mean. The normal distribution and its shape actually arises from many different variables found in nature, such as weight, height, volume, blood pressure, and many more. This is why the normal distribution is commonly studied. For example, exam scores are known to follow a normal distribution. Some people do great on exams, some people do poorly on exams, but a large majority of people score near the average or the mean. In this example, the average exam score is 50 because it is located in the middle of the curve. Now that you know what a normal distribution looks like, we need to talk about the population mean mu and the population standard deviation sigma. Both of these tell us important information about how the normal distribution looks. We'll talk about the population mean mu first. The population mean mu characterizes the position of the normal distribution. If you increase the mean, the curve will follow and move towards the right. And if you decrease the mean, the curve will still follow and move towards the left. This happens because the data will always cluster around the mean in normally distributed populations. As a result, the value of the mean determines the position of the normal distribution. On the other hand, the population standard deviation sigma characterizes the spread of the normal distribution. The larger the standard deviation, the more spread out the distribution will be. And the smaller the standard deviation, the less spread out it will be. Notice that when the spread increases, the curve gets much flatter. And when the spread decreases, the curve gets taller.
So remember, when we're dealing with standard deviation, we are always commenting on the spread of the distribution, okay?
The reason for this is because the normal distribution is a density curve, and the total area of any density curve must remain equal to 1 or 100%. So changes in the width of the curve must be compensated for by changes in the height of the curve, and vice versa. Overall, here are some points about the normal distribution. The normal distribution is unimodal. This means that the distribution has a single peak. The normal curve.
So this is a concept we like briefly kind of mentioned through a question in Lumen. And then I was like, don't worry about it, right? So if it did appear in the midterm, I just gave you guys full credit for this. But now you like heard it enough that I think you'll know. Unimodal, uni meaning one. So the mode is there's one peak, right? Mode meaning where most of the data lies, right? So it's unimodal when there's a single single peak. And the normal curve is symmetric to its mean, right?
Curve is symmetric about its mean, so you can clearly see that the distribution can be cut into two equal halves. The parameters mu and sigma completely characterize the normal distribution. The population mean mu determines the location of the distribution and where the data tends to cluster around. The population standard deviation sigma determines how spread out the distribution will be. The notation given to a population that follows a normal distribution can be written like this. Although it looks scary, it means what it says. For the variable x, it follows a normal distribution and has the mean mu with a standard deviation of sigma. Now that you've been introduced to the normal distribution, we can talk about the 68, 95, 99.7 rule.
Okay, so up to this point was a very good review of some of the concepts that we covered, right? It went all the way back to parameter versus statistic, right? We're always dealing with whether the data set is about the entire population, or is it literally a portion of it, a sample of it, therefore we're dealing with the sample, and therefore we will be dealing with statistic representing all the sample stuff. And then of course we went through the normal distribution, talked about unimodal, the mu and standard deviation, mu being the average, standard deviation commenting on the spread. And for our purpose, we will mostly be looking at unimodal distributions with one peak. And we're dealing with normal distributions right now. In particular, we are dealing with the standard normal curve, okay? In relation to that, we are going to learn a new concept here, okay? So this is the 68, 95, 99.7 rule, also called the empirical rule. And it'll make sense why it's called that, even though it doesn't seem like a very intuitive name. And then we'll do some problems on that, okay?
If we were measuring the heights of all students at a local university and found that it was normally distributed with a mean height of 5.5 feet and a standard deviation of half a foot or 0.5, we can construct a normal distribution as follows. From here, we can create intervals that increase by the standard deviation. So we'll have 6, 6.5, and 7, and on the other side, we'll have 5, 4.5, and 4. So what the 68, 95, 99.7 rule says is that within one standard deviation away from the mean, it contains a total area of 0.68 or 68%. Because of this, we can say that 68% of the population are between 5 and 6 feet tall. And if you go 2 standard deviations away from the mean, it contains an area of 95%. This means that 95% of the people in the population have a height between 4.5 and 6.5 feet. And finally, within 3 standard deviations away from the mean, it contains a total area of 99.7%. This means that for the population we are studying, 99.7% of the people are between 4 and 7 feet tall. Now you might be wondering, what happens if we go 4 standard deviations away from the mean, or 5 or 6 standard deviations away from the mean? And to answer that, you actually can. A normal distribution actually never touches the x-axis. It continues on to infinity. So you can go as many standard deviations away from the mean as you want, but the area contained within these regions will be very, very small. The 68, 95, 99.7 rule is a great way for approximating the areas of a normal distribution. And this works for any normal distribution no matter what shape and size. So let's do some practice questions. Feel free to pause the video at any point so you can try these questions for yourself. Question number 1. The normal distribution below has a standard deviation of 10. Approximately what area is contained between 70 and 90?
Okay, so as a class, we are actually going to do this together right now, okay? So if you have, just get like a pen and paper, like I'm going to do right now, and go ahead and maybe draw out the area that it's referring to, right? So you'll have a standard normal curve that you're drawing, and then maybe make some lines, and I'm gonna see that in the middle it's 70, and then you go 2 standard deviations to the right in the positive direction, and that's where 90 is, right? So what area is covered by this, right? What area approximately? So if I were to, this is a little bit difficult when I was doing it. So if I were to show, it's in the opposite direction. So this is the area that is covered, or this is the area that the video is asking about. What percentage of the area, remember the area is 1 or 100%. So if it's 100% under the curve, what percentage of area is covered by that shaded area that I have near the camera? How would you go about doing that, guys? Knowing the 68, 95, 99.7 rule. And this is the type of questions we're going to do today, as well as you'll see that on the next midterm, as well as on the final. This is kind of how it's going to look for these types of questions. Okay, so you have to remember the definition of 68, 95, and then 99.7 rule. So let me ask you this. Let me draw this. Oh, you know what? I actually have coloring pens today. What? All right. Let me know if you can actually see this. So let's say if I ask you this question. Oh, let's see. So see the blue? See if I have the right light. Is that gonna make it better? No. So the blue area, what percentage of the area is covered by the blue colored shaded area?
At 95%?
Very good, Savannah, right? 95%. However, let's see if I can do this. However, what it's asking is only the darker, maybe I should use a different color. I want to use kind of like a purple on top of the blue, but it's only asking for that darker region that I colored on my thing. Okay, so how would we calculate that area, guys? There's a reason why I started with 95. And then we're only looking at, what do you guys think?
You divide that in half.
Excellent, exactly. So that's how you're gonna find out the area under the curve using this 68, 95, 99.7 rule, okay? As long as it's a standard normal curve, this particular rule, it's called the empirical rule, will apply. Maybe it won't be, the question will not be asking exactly one standard deviation away from the mean in both directions, or 2 or 3, but it might be asking for half of that or half of this, and how much area is covered by that. Then that's how you're going to utilize that rule. Maybe it's half of that area and half of this area. In this particular case, it's half of the area of the 95%. So it's going to be, what is that? 42.5? No, 47.5? Yeah, 47.5%. Okay, so that's how we're doing it. So let's take a look at how he solves it.
In this question, we know that the population mean is equal to 70 because it's in the center of the distribution. We also know from the question that one standard deviation is equal to 10, and we can see this because each interval goes up by 10. According to the 68, 95, 99.7 rule, we know that there is an area of 95% contained within 2 standard deviations of the mean. 2 standard deviations to the right gets us to 90, and 2 standard deviations to the left gets us to 50. According to the 68, 95, 99.7 rule, this means that there's an area of 95% contained within this interval. However, we are only interested in the area from 70 to 90. So dividing this area by 2 gives us our area of interest. 95% divided by 2 gives us an area of 47.5%, and that is our answer. Question number 2. For the normal distribution below, approximately what area is contained between -2 and 1? In this example, we know that we have a mu of 0 because 0 is in the center of the distribution, and we know that we have a sigma of 1 because each interval goes up by 1. To approximate the area between -2 and 1,
Okay, I'm going to stop right there. So now we are going to approximate the area that is in this screen right now from -2 to 1. Okay, so go ahead and draw that on your note somewhere. And then think about the 68, 95, 99.7 rule, and then find out how you will be able to calculate that dark blue area. Okay, so remember, it's not going to be exact, just like the previous problem. You're going to have to manipulate the 68, 95, and 99.7 rule in one way or another to calculate this area. It's not going to be like a one-step thing. It's going to be probably like 2 steps or something. So draw this out and try to understand what area it's covering. I'm doing the same thing, drawing it on my notepad. And then calculate what would be that area. So let's see if we can come up with a solution. Okay. Once people get a solution, shout it out or put it in the chat. Let's see what you guys get. All right, so Savannah got 71.25. Anybody else? Savannah, tell us how you got that number.
Did I do that right?
I'm not gonna say just yet, because I want to hear from other people too.
So I did, it's within 2 standard deviations, which is 95%.
Mm-hmm.
Did the 95 divided by the 4 spaces it was, just to see which each space between the two. Does that make sense?
That does make sense to me. I know what you did. I'm just not gonna tell you if that is the right way to do it or not. I want to see what other people got. What did other people get?
I got 81%, but I don't know if that's right either.
81%?
Yeah.
Okay, so Akili got 81%. Can you tell us how you got that?
Yeah, I did the 95%, or because the 95%, and then I divided that by 2.
Mm-hmm.
And then I went from like the -1 to the 1, and that's the 68%. So then I divided that by 2, and that's the 34. And then I added the 47.5 and 34, or 47.5 and 34.
So you got 81.5 in the end, right?
Yeah, that's what I meant.
Okay, all right. So guys, we have one person who got 71.25, and then we have another person who got 81.5. Equally, I feel like pretty reasonable reasons how they got there. So what do we think as a class? Anybody got a different answer? Or I'm with Savannah, I'm with Akili. What do you guys think? Alexis did it the same way Akili did and got 81.5. Okay. Anybody else? It's difficult because this is like the first time you're doing it. Instead of kind of showing you the solutions first, I'm actually kind of purposely making you guys do it and struggle a little bit, okay? And that's fine. That's to be expected. Yep. I definitely think it would be confusing. And I think because of these two solutions, and I expected these two solutions, it is definitely confusing. Because when you listen to each person, it both sounds pretty good, right? It's like, oh, that makes sense. But there obviously probably is one answer, so it's a little confusing. All right, anybody else at all who got something different, or I agree with either Savannah or Alexis and Akili? Okay, so I'll give you one hint then. So one of those answers is correct, but only one of them. And I'll say this. When you look at the standard normal curve, and let's say, I kind of drew it over here. Oi, the other way. So when you look at it, so there's a light blue colored one, and then there's a dark blue colored one, and then I can also, maybe I'll color this area too. That's just to point out, let me do a different color as well, guys. Let's see if this actually works. Okay, so I have 4 different regions in my picture, guys, right? And you can see the lines are kind of what you would expect. 0 is the mu, and then it goes in each direction 1 standard deviation at a time. So the entire area that is colored with one color or another, it is the 95% area, right? Let me ask you this question. So each color is like a chunk, if you will. If I divide 95% by 4, what happens? Will the answer 95 divided by 4, would that equal each one of these colors, guys?
No.
No, right? Just look at it. They're not exactly the same size, especially the dark blue and the red. If you put it right next to each other, you know the red is less area than the dark blue one, right? So what Savannah did is a common mistake a lot of people do, to think that they're equally dividable, but that's not true, because if you wanted to equally divide it, then it will have to be something like this, where I drew the 4 bars, right, guys? And they're all the same height and the same width. Then you can divide that entire area into equal 4 parts. But as we know, that's not how the standard normal curve looks, okay? So it is very intuitive almost to want to get the area, oh, and there's 4 pieces, so I divide it by 4, but that's only in a scenario where the 4 pieces are actually equal sizes. So no, you wouldn't do it that way, though that does, for a second when somebody told me that solution, I'm like, oh, that makes sense. No, you want to think a little carefully because of the different shapes it is. So what you want to do is, as Akili was saying, it's going to get all messy, but I'll try it. Now that I have all these coloring pencils. So the red colored one was just to show example, but that circled area and the red circled area is going to be half of 95%. And then that kind of black circled area with the dark blue region is going to be half of the 68%, based on the empirical rule we just learned. So yes, you're going to do half of, and I have the solution right underneath, half of 68, which got me the 34. And then you're going to do half of 95, which got me the 47.5. And you're going to add those areas together to get 81.5. Okay, so this is a very typical question you would encounter in relation to the 68, 95, 99.7 rule. Okay, I'll show you, since mine is all like kind of messy, we'll see in the video how he solves it, okay? So it's gonna be cleaner because it's like full screen and whatnot, okay? So the exact solution I just told you.
We will use the 68, 95, 99.7 rule. We can strategically divide this area into 2 parts so that we can easily incorporate this rule. We'll start with the right half, which goes from 0 to 1. We know that 1 standard deviation away from the mean gives us 68%, and half of this is 34%, giving us our area from 0 to 1. The next half goes from 0 to -2, but we know that within 2 standard deviations from the mean, we have an area of 95%. Dividing this by 2 gives us the area from 0 to -2, which is equal to 47.5%. And finally, to get the total area contained between -2 and 1, all we have to do is add these 2 areas together. And when we do, we get a total area of 81.5%. If you found this video...
Okay, does that make sense? I know Naja was a little confused, and I bet a few other of you guys were. Does that make sense? Okay, Christina says yes. We're gonna do a few more problems like this. So if you're not completely comfortable, that's okay. But at least the concept, I'm hoping that it's clear, right? There's a reason why we, take like half of 95% and half of 68%. And there'll be times where you're gonna use half of 99.7% and et cetera, et cetera. But you won't be dividing any of those areas into equal parts. There's no real part is really equal, except when it's in half, it's symmetrical, right? Standard normal curves are symmetrical, so you can say this half and the other half are the same. That much we can do, okay? And that's kind of like the extent of what you will be using with the 68, 95, 99.7 rule, okay? But as you know, we are still talking about the normal curve, the density, so the area underneath the curve, which we were dealing with last week as well when we were talking about the left tail areas and the right tail areas and the areas in between. Okay, so what we're doing today is Still dealing with the area under the curve, and we're gonna continue to do left tail, right tail area in between two z-scores things, but just go into a little bit more deep, and then added on to that is a 68, 95, 99.7 rule, okay? So we'll cover chapter 15 and 16 quite quickly because it is pretty much the same information. And then the majority of the class today, we're gonna just continue to do some problems together. And we're gonna do a whole Lumen practice problem set together in class, okay? So you won't have to have homework and stuff. Okay, so let's all go to, if you guys remember, the Mathplosion textbook, chapter 15. If you don't already have that link already kind of saved in your favorites, then typically, as you would, go to Blackboard and then go to content. And we're finally at kind of module 4, as I'm calling it, right? Though those numbers don't mean anything. So go to 4, normal distribution. And then at the very top are usually the list of the book chapters, right? The second one should be chapter 15, which is called standard normal table. So let's open that up. And then I'll try to open it up my screen as well so that we can all see it together. But go to chapter 15. We are going to do standard normal table. And that's short, and then we'll move on to chapter 16. Okay. Once you have chapter 15 open, and chat me and tell me that you're ready. You will be seeing something like this.
I'm ready.
All right, great. Awesome. People are showing me that they're ready. Good, good, good. Okay, so I'll have my chat on this screen at the top, but you'll see something like you see on my screen as well. Chapter 15, standard normal table. All right, great. Let's see, Paulina, can you start us off with the first two paragraphs here?
Sure. This section shows how to use the standard normal table to find left tail areas. So we will be finding the areas for examples like these. The standard normal table, Z table, we use it in Appendix A. This table contains only left tail areas in it. So in this section, we concentrate on showing examples of finding left tail areas using the table.
Good. Obviously, this is a typo. This should be areas, right? Okay. So I'm going to go ahead and click on Appendix A, and you can do the same thing. And so this is a complicated, well, not really complicated, but it's like kind of like looks pretty complicated, right? A very, very long table. And this is called the Z table. What it is that it's basically what Google spreadsheet will calculate for you. You know how we did equal norm S dist, and then we'll put in a z-score, and then an area would come out as an answer. This is exactly that sheet, basically. So it's kind of like saying, well, the z-score is negative 3.03. See where my cursor is? Negative 3.03, and where that meets is 0.0012. So that's an area of 0.12, right? So that's exactly what this table is. And it used to be, I mean, still is, that once you get a z-score, you would look it up on the z table and then figure out the area from there, right? And it's still used, but thankfully now we use kind of software like Google Spreadsheet or Excel to just type it in and it will look up the Z table for you. So that's kind of what we've been doing. But if we wanted to do it properly, this is kind of the proper way to look up a score, look up an area under the normal standard curve, okay? So that's all it is. But as you know, we have more convenient ways of doing it. But just know that that is kind of the standard way of doing it. So if you have, and that's a left tail, that's for left tail. Remember when we do the spreadsheet, we do equal norm S dist and we put in a z-score, then immediately it will tell you the left tail areas, right? That's exactly the same with the z table, okay? So just like we did when we wanted to get the right tail area, we would do 1 minus left tail area, right? That's the same with the appendix, this z table, is that you would find the area with the given z-score, and then you would just do 1 minus that area you found to arrive at the right tail area. Okay, so basically exactly the same as the way we've been using the Google spreadsheet. Okay, so something like this, you know, -125, all we would do is this right here, right? In a cell, we type in equal norm S DST, and then inside the parentheses, you put in the z-score. Or if you had the z table, look at this area that's highlighted in black. You go -1.25, right? Because this is 0.5. So it's together, it's -1.25, and that's the area that you get, which is about 10%. Right, and if you look at the left tail area that's shaded in, you can kind of be like, maybe, yeah, that's around 10.56% of the entire area. So you can kind of confirm it that way. So this is how you would do it, and that's pretty straightforward. And left tail area, if it's 1.32, nothing different, exactly the same. This is where I'm highlighting right now. This is how you would do it in the Google spreadsheet. Just plug in that number, or if it was a z table, you'll look it up 1.32, and then it shows you it's about 90% of the area under the curve. And if you like look at the shaded area, you could be like, oh yeah, that does seem like the majority of the area under the curve, and kind of agree with that. So those are easy because they're left tail areas, and this is just another example of it. Left tail, left tail. Is there, oh, there's no right tail in this particular section. Okay, so we'll just stick to the left tail for now. I do think there's a typo somewhere. This is 0.07, so that's all good. -2.03, negative, okay, so there's no typos here. Okay, so exactly the same as the two above questions. You would normally just put in 0.07 in norm S dist, right? Normal, S standing for standard, and dist standing for distribution, right? You just plug in the number. Or you go to the Z table that is available to you in the appendix, right? And you go 0.07, you find that it's 0.5279. And then you can kind of look at it and be like, yeah, that's a little bit above 50%, right? 52% of the area. And you're like, okay, that sounds great. And then again, this is a negative z-score. So it's just giving you all kinds of examples in the positive and negative z-scores. You do this in the Google spreadsheet, which is totally acceptable, or you can look it up and find that area, which is going to be about 2% of the area under the curve, which you can conclude from here. Very good. Okay, so that's all it is. All it is that there is a standard normal table that exists and that is available. And this is another way you could find out a particular area to the left of a z-score, besides using the Google spreadsheet way. Just know that that is available, okay? So let's go to chapter 16. And this is where we will cover not only the left tail areas, but we'll cover the right tail areas as well, okay? All right, so left tail areas, right tail, and also the areas between two z-scores. Okay, so left tail area is kind of simple again, nothing crazy. The z-score is 1.52. So this is how you would do it in the Google spreadsheet. Or again, you can do 1.5 and then 2 and be like, it's 0.9357. So this area that's shaded must be around 93 or 94% of the entire area. Okay, easy peasy. Left tail, this is also pretty straightforward. It's -0.87. So you could look up -0.8 7, and here you go, and that's about 19% of the area under the curve. All right, right tail areas, right? We're calling it the 1 minus trick, okay? So because the z-table and because of the equation norm s dist will always give you the left tail area. Well, then how do we tackle the right tail area? All you gotta do, you take the same step, right? Of like, let's say it's negative 1.32 you're looking for, so you do that. So you do norm s dist with negative 1.32 in the parentheses, but that's not the end of it because this is going to give you the left tail area. So what you do is that area you calculate, you're going to subtract that from the total area, which will leave you with the right tail area. So you can imagine, is there a table somewhere that we is showing? Oh, it's not showing you the table. But if you were to look up negative 1.32 in a table, it will give you something, right? It will give you, I think it was this one, 0.0934. This will show up in the Z table. And all you got to do is subtract that area from 1, which will give you the right tail area. Exactly the same thing we were doing as last week. Okay? I thought there was negative 1.3, negative 1.3. There doesn't seem, I thought I like found where a minus sign was missing, but I can't seem to find it anymore. Okay, so let's do this run right now. Let's do it on our like piece of paper or maybe in a spreadsheet. What would be the right tail area? So this shaded area for 0.52, a z-score of 0.52. So go ahead and try it out. So you can use the appendix. So maybe I can do that for you guys. Where is the appendix? Appendix A, 0.52, right? So I'm gonna go, it's a very long one. And you can also use Google's spreadsheet, but I'm gonna go and do 0.5 right there, 0.52. So it's gonna give me 0.6985. But what's the trick here, guys? Am I looking at left tail or right tail?
That would be left tail.
Oh, I thought I said it was a right tail question. What was it, guys?
I thought it was a right tail question.
Oh, okay, right tail. Yes, that's what I thought. 0.52. Where are we at? 0.52. Here we go. Right tail area. Okay, so I just looked up the z-score 0.52 in the z table, and I got 0.6985. Am I done to answer this question, guys?
No.
Nope. What do I do?
Subtract that from 1.
Subtract that area from 1. Very good. So what do I get, guys?
0.3015.
Right, I got also 0.3015. So let's scroll down. So it does 1 minus that area, and it's about 0.30. So if you want to do it in percentage, that's about 30%. 30% of the area is in this right tail region that's shaded. Okay, nothing different than what we did last week. Okay, and this one too is similar to last week, right? All we're trying to do is now look at an area between two z-scores. Okay, so if it's this z-score and this z-score, so the idea is that, as we learned, this one, the z-score that's further and closer to the right side should be the one first, and then you subtract the z-score area that's more to the left, right? However, if that's confusing, as I said, if that's confusing, you can just look up these two z-scores, right? As in you plug in the z-scores and get the area for it. And all you have to do is that you have to subtract the smaller one from the greater one, because an area by definition cannot be negative. So if that's confusing which one to subtract from which, all you have to do is plug in the z-score like this, right? Equal norm S dist 1.65, because that's one of them, and norm S dist 0.52. And then you'll get the area underneath the curve, like the left tail area specifically. But if you don't want to think about that, don't worry about it. And then all you got to do is use the greater one first and then subtract the smaller one, and then you'll know the area in between, which is about 25% right there. Okay, so exactly like we were doing last week. So let's do one together. So what if it's this one, guys? Let's do Z1. So try that in your notebook. Z1 is equal to negative 1.53. And Z2 is equal to 1.23. Okay, so this is question example 16-6. So try this, and let's see what area you get for the area in between. Try it, and once you get it, tell me or write it in the chat. Okay, we are trying to find this gray area, the area in between. 2 z-scores. All right, Christina got 0.83. Anybody else? Do we agree? We don't agree? Savannah agrees. Anybody else? How's everybody else doing? Good. Samantha agrees. Emily agrees. So what was the z-score you got for negative 1.53, guys? What did you get for negative 1.53? I mean, the area under the curve for the z-score negative 1.53. What did we get? Anybody? 0.06, yep, that's around what I got. And then what was the area under the curve for a z-score of 1.23? About 0.89, excellent. So which one do we subtract from which? Z2, which one was Z2? Okay, Z2 is what, right? Good, Savannah is saying. So we subtract the Z1 from Z2. The bigger one comes first and then minus the smaller area, which ends up giving us about 0.83. Very good, right? Okay, any questions about getting the area under the curve that is left-tailed, right-tailed, or area in between? All right, well, if you do, you can still ask, obviously. So now what we're gonna do is that we're gonna get some practice on right tail area, left tail area, area in between, and then the 68, 95, 99.7 rule. Okay, so as a class, we're gonna do it together. So everybody go back to Blackboard, and then we're gonna actually do a Lumen problem set. So let's go to, what do I call it? MA222 OER. And then if you go in there, all the way at the bottom, there's like a link. Let's open that up. So I'll share my screen to show you where that would be. So under normal distribution, no, sorry, not there. MA222 OER, right? I'm gonna go there. I'm gonna scroll all the way to the bottom, and it's called practice problem set, z-scores and normal curve. So go ahead and click on that. And if it actually, oh, I guess I started it. I'm gonna reset it. Okay. So let's start it. Okay, and then you should be able to see all the questions. I believe these particular questions might be the same numbers, but it is possible that they're different. I forget how I set it up, okay? But let's start with question 1. All right, on a recent quiz, the class mean was 69 and standard deviation of 2. Is it the same, guys? Or is it a little bit different?
I have different numbers.
Okay, but the question type is similar. So let's do it together, guys. All right, so we have, and calculate the z-score. So we know how to do that, right? You take the value of interest minus our mu divided by standard deviation. So go ahead and calculate your z-score and then tell me if it's usual or unusual. Remember in the video we watched today, we were talking about, when we're talking about standard normal curves, you know, 1 standard deviation away, 2 standard deviation away, 3 standard deviations away is going to cover about 99.7% of the data. And you can go 4 standard deviations away, 5, 6, 7, it can continue, right? Because the curve will never actually touch the x-axis. But now you know there's going to be just very, 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 very little data when you go that many standard deviations away. So that's how it would guide you. That's how you would be able to calculate, answer this second sub question. Okay, so Alexis got 1.67 and says not unusual. I have a different number, so maybe, let's see what I'll do. So I'll do 65 minus, what is it, 69, and then divided by 2 equals, I got a -2. And then it's not unusual, submit question. Got it right. Yeah, your numbers probably are different, but that's okay, right? You plug it in, and then you should get it correctly.
265 minus 69.
Yes, right? Remember the equation goes, I'll type it in I don't have the symbols ready. So remember this one? It's the value of interest, right? That's your x. It's minus the mu, and then you divide that by the standard deviation, which will give you the z-score. Okay? So we'll start with one of those basic questions. And yes, if it's pretty much between within 3 standard deviations away, whether that's negative or positive, then that's probably very usual, right? It lies in where the majority of the data will lie. Okay, good. All right, so you don't have to necessarily follow my pace exactly. So continue to do something, but we'll do these questions together, okay? So look at this. You have adult men with heights of a mean of this and standard deviation. Find the z-score, same thing. For me, the numbers might slightly be different, guys, but you do 60.5 minus 69 divided by 2.8, and you'll get the z-score. Okay, so go ahead and do that question. And then question 3 is kind of what we call the backwards question, right? So we're gonna start with the z-score. You start with the z-score, and then you kind of have to backtrack and calculate an x from this formula that I have in the chat, right? So this is a backward question. So go ahead and do question 2 and question 3 and see if you get it right. Moving forward, starting from this one, there should not be a situation where you got everything right, but you only got partial credit. I've been very careful in making these now, so that should not occur anymore. Let me know if you're having any issues solving those questions, okay? My goal is I really want to get to question 4, which is where the 68, 95, 99.7 rule begins, okay? Let me know in the chat if you're like ready to start question 4 and 5. And you can start it too, you know, you don't have to wait for me, but I do want to go over it together. Am I right? I don't see Abby, Amanda, and Morgan. Is that correct? Any of you guys showed up late? Okay. All right, I have about 6 of you guys that said already. I'll give it maybe a few more seconds. And try it out if you're ready. But you can also wait if you want. Oh, maybe it's stopped raining. God, it's freezing today. One, 2, 3, 4, 5, 6, 7, 8. Okay, 8 of you guys are ready. That's a good amount. Okay, so let's go. I'll share my screen again. So I don't know how much that would help, but okay. All right, so I'm at number 4. And remember, the numbers might be slightly different, but the idea behind it is the same, right, guys? Okay, so there's a physical plant at the main campus. Receives daily requests to replace fluorescent light bulbs. The distribution of the number of daily requests is bell-shaped. So this is another now term that I think at this point you guys should know. Bell-shaped just means it's normally shaped, meaning that it's a normal distribution, okay? With one peak in the middle. It has a mean of 44, so that's something you might want to write down, and it has a standard deviation of 4. Okay, so we can apply this rule, which is called the empirical rule, because it is bell-shaped, because we now know that it's a standard normal curve. Okay, so what is the approximate percentage of light bulb replacement requests numbering between 36 and 44? So whenever you get a question like this, the best way to start is to draw it out, you know, so you can have an idea of what you're looking at. Right, so you'll draw, I'll make a big draw. And then in your standard normal curve, you will mark the mu in the middle. So that's gonna be 44. And then kind of deviate up so that it has 1 standard deviation away, 2 standard deviation away, and mark it on your graph, and maybe up to 3 standard deviations away, okay? So for example, I'll show you what I did. So I have on the other side, I have something like this. Okay, so the very basic one, I have a normal curve, and then I mark that in the middle, it's 44. And then I'm gonna go to 1 step on each side, like 1 step as in 1 standard deviation on each side. And then I'm gonna start marking the x-axis. So I have something drawn like this, so that it indicates, you know, 3 standard deviations away from the middle, okay? And I know from the question that my standard deviation is, it says it's 4. So what I'm gonna do is I'm gonna add 4 as I go to the right, right? So 44 plus 4 is 48, so that's 1 standard deviation away. And then 48 plus 4 is 52, that's 2 standard deviations away. And 52 plus 4, 56 is 3 standard deviations away, okay? And now I gotta do that for the other direction. So I'm gonna do 44 minus 4, so 40 is -1 standard deviations away. 40 minus 4, 36, and 36 minus 4, 32. So now I show you that I have something like this. Can you guys see my lighting is not too great, but that's my standard normal curve that I have, 44 in the middle, and it's going 4 up or 4 down, depending on which direction I'm going in terms of the standard deviation, okay? Now I look back at my question. This is how you kind of do it. It says, oh, I want to know the area between 36 and 44. So now I'm going to color it or shade it. So now I have my curve drawn with all the labels, and now I have the area that I want to figure out all shaded. Okay? And then I'm going to think about the 68, 95, 99.4, 99.7 rule. Okay, so for me, I can take a look at it and I'm like, this is half of 95% of the area. So I'm gonna do 95 divided by 2, which will give me 47.5. So my answer probably is gonna be 47.5. Okay, according to my question. And so I'm gonna do 47.5 and submit question, and I got it right. Remember, this is percentage, so we're dealing with percentages. And then don't add the percentage sign in it. That might mark it wrong. All right, are we here? Like, did people get that? If you're good, try question 5. If you're not and you want me to do a solution for your particular problem, let me know. And then you can share your screen. So same idea for question 5, and I believe question 6 as well. And then question 7. So let's do, I'm gonna skip question 5 and 6, and I'm gonna go to question 7, okay guys? So if you have done at least 1 or 2 questions or whatnot, and even if you haven't done up to question 6, let's go to question 7. So it's gonna be, the numbers are gonna be a little bit different, but this is, I think, as difficult as a question will get for the 68, 95, 99.7 rule question. Okay, so I'll wait just for a second to finish up what you guys are doing, but if you're ready, then let me know in the chat that we're ready to do question 7 together. Okay, and I'll give you more time to finish question 5 and 6, but we're gonna start with question 7 because this is like a little bit more complicated. Okay, Achilles ready. Steffi's ready. Liam's ready. Gianna's ready. Sam, Laura, Savannah. Christina, Polina, Emily. James Lynn. Alexis. Okay, I'm gonna move on. Ashley, Apurva, Joy, Carrie, Deidre, you guys all good? All right, so let's start with, good. Okay, so let's start with this. So there's a company manufacturing widgets. The important part is like the distribution is bell-shaped. Okay, don't forget this bell shape. So basically we're dealing with a standard normal curve, meaning that we can apply the 68, 95, 99.7 rule, okay? All right, so we have a mean of 60 and a standard deviation of 8. All right, the empirical rule is the 68, 95, 99.7 rule, okay? That's just another way of calling it. Okay, so we're gonna try to find 68% of the widgets lie between this number and that number, okay? So again, you're gonna draw out your normal distribution curve. Okay, so I'm gonna go ahead and draw this out. You guys should get pretty good at this. And I'm gonna draw a line in the middle. That's where your mean is, and I'm gonna write down 60. Remember, your numbers might be slightly different, okay? Go ahead and mark your 1, 2, 3 standard deviations from the mean, kind of as accurately as you can, but it can be rough, right? It doesn't really have, nobody's like saying anything about your drawing. And then for me, I'm gonna go 8 up or 8 down, depending on which direction I'm going for each standard deviation, right? So for in the right direction, I'm going to do 60 plus 8, so 68, and then 68 plus 8, 76, and then 76 plus 8, which is 84, right? And then the left direction, I go 60 minus 6, so 54, and then minus 6, so that's 48, and 42. And then, I'll stop sharing. So my curve looks something like this. Okay, I have it all labeled, kind of like a bell curve, and then I did from 60, and then I go up and down. Okay, and then I know the 68% from the empirical rule is 1 standard deviation from the mean. So I'm going to shade that area, and in my particular graph, it's going to look something like this. Okay, and then I can look at the numbers that indicate what it lies between on the x-axis, and that will be the answer for my first question. Okay, so for me, because my standard deviation was 8, it's between 54 and 68 for me. Okay, the numbers might be slightly different for you guys, but remember 68% of the area under the curve is going to be covered by 1 standard deviation from the mean in both directions. So that's going to be that one. And then you're going to go to B, and this is kind of like the typical questions we've been solving so far. I'm going to find where 44 is on my x-axis, and I'm going to also find where 68 is. Oh, maybe I calculated that wrong. It's 44. And then I'm going to color the area. Okay. I'm supposed to subtract 8. That's why I did wrong. 52 here. And 5, 2, 6, 44. Oh, it's 44. Okay, so I did that wrong again. So I did it wrong, but anyways, it's this area. Okay, so for me, I colored it initially wrong, but anyways, I'm trying to find the red area in my graph. Okay, so I'm going to take a look at it and see. Well, 1 is like half of, I think, the 68%. And the other red part is half of 95%. So I'm going to do that same thing like we did in the second question in the video. So one of this is going to be 68% divided by 2. And the other part is going to be 95% divided by 2. So I'm going to add that up, and I get about 81.5% for my second question. Okay. And then I'm left with the last one. Which I believe is going to be the most complicated one. Okay, so for me, It wants to know what percentage of the widget lies above 36. So 36 on my thing, use a different color, is 3 standard deviations to the left, and it's any area above this. So let's see if you can kind of see it in my graph. But I have 36 here, right here, and it's everything above it, everything. 36 are all the way here, and it's every area above it. So that's probably the toughest one. So how would we calculate that? Let's see who comes up with the. Okay, so Naja doesn't understand B. Let's do C first, and I'll go back to B, okay? Let's start out with C, and then I'll go back to B, because they're basically similar questions, just kind of like a different flavor, okay? And I'll draw a new one, Naja, for you, so I can address B. Or Naja, in the even better, in the chat, type in the numbers for your question. Give me the mean and standard deviation and what the question is asking. So I'll draw a graph based on your numbers, okay? Lies between 20 and 65, okay? Standard deviation is 9. Oh, oops. All right, so for Naja's question, I drew it out. Okay, so here is my graph according to Naja's numbers. Do you see that? So the mean is 38 and standard deviation is 9. So based on that information, I drew out my normal distribution. So you see that I start at 38 and each kind of like little section is going 1 standard deviation away from the mean. So when it goes 1, it's like 29 on the left and 47 on the right, et cetera, et cetera. And then it says, what percentage lies between 20 and 65? So now I colored that in purple. So how would I go about calculating that? Okay, so you have to think about the 68, 95, 99.7 rule. So you take a look at your thing. I'm going to take a look at it. Let's see. So I would say this side and this side is how I'm going to look at it. So let me just draw this out. I'll use a different color. I'll use this one. All right. So because I'm sticking to the 68, 95, 99.7 rule, I would divide the area that I need to calculate in these two sections where I have the red arrow and the green arrow. So the red arrow, if you look at it carefully, is going to be half of 95%. And then the green arrow is going to be half of 99.7%. Yes, Christina, you're correct. And then I'll calculate half of each of those and add them together. And then I will end up with that entire area that is colored in purple. Naja, does that make sense?
I just don't understand how how you're figuring out to use half of it.
Okay, let's see. So let's focus on my picture right here. Do you see the 3 red lines, vertical lines?
Yes.
Okay, so tell me, between the outer 2 vertical lines, so kind of like the 2 shorter ones, in between that, what percentage of the area is covered based on our empirical rule? So if I use my pencil here, from here where it's 56 and all the way to here, so this area, according to our empirical rule, what percentage of the area is covered?
68.
No, these are 2 standard deviations away, so only this area will be 68.
Okay.
Yeah, so it's 2 standard deviations away. It's a little hard to see, but you can see that this is my mu, and if I go 1 standard deviation, it's that way, but I'm going 2 standard deviations away, right? Same on this side, 1, 2, I went 2 standard deviations away. So it's covering 2 standard deviations away from the mean in both directions. So how much area is covered?
95.
95, right?
Yes.
Good. So 95, and then look at the area, the kind of the horizontal arrow I drew. That is just half of that. You see that?
Yes.
Yeah, so that's half of 95%. That's how I'm getting that area. And then the rest of this part that's colored in purple, that one is half of, starting from this area all the way to past that red line here, 3 standard deviations away, that's half of 99.7%. And so that's how I got that green area right there, the area. That's how I'm getting it. You kind of have to get used to doing a few questions like this to kind of immediately see.
Yeah.
Because there's no kind of magical way of doing it. So now I have the green arrows, and that's going to be 3 standard deviations from the mean. But I only want to have this part. This area is what I'm interested in. So I do half of 99.7. Just like we did with the red area, from here to here is 2 standard deviations away, so it's 95%. But I'm only interested in this area, half of that. And together, that half and this half is the area I'm interested in. And that's how, as Christina wrote in the chat, we're going to do half of 95 and half of 99.7.
Okay.
Yeah. So you just have to, it's not like really, there is like a certain way to do it, but you kind of have to just get really used to deviating it up with the 68, 95, 99.7 rule. Okay, so always think in those terms when it's asking this question. I mean, anytime it says it's using the empirical rule, it's a bell-shaped thing, then you're gonna think about whether the whole area, the area that of interest is covering 68, 95, 99.7, but most likely that will never be asked, right? Because that's too easy. So what's gonna happen is that it's gonna give you a combination of half of something, half of 68 or half of 99.7, half of 95, half of 99.7, half of 68 and half of 99.7, or something like that. So always think in those terms and try to find those areas and define it. Define the chunks of areas that this is half of this is half of this, and this is half of this, because that's the most common thing you're gonna see.
Okay, thank you. So then you add the two together?
Yes, right, because it's asking the entire area between 20 and 65. So you do have to add those areas together to answer the question. All right, so let's do one more. Christina's asking. All right, so let's do, maybe it's a good practice for everybody to also do it together, okay? So we're gonna have a normal curve. Christina says she has a mean of 47, and then sigma is 3, okay? So I'm gonna draw 1, 2, 3 standard deviations away from the mean in both directions with 3 apart, okay? So it's gonna be 50, 53, 56 in the right direction, and left it's gonna be 44, 41, and 38. So it wants me to get the area between 53 and 56. Aha! That's a tricky one.
Yeah, I thought I did like 1/6 of 99.7, but that was.
But remember, we can't evenly divide these, right? They're not equal parts. So we're gonna have to use some other kind of trick to do that, right? All right, so this is a very good question. Let's all as a class do this together. This is a very, very good question, in my opinion, okay? And I'll give you some hints. Give me 1 second. I'm gonna use my same colors. All right, my hint is this. So I marked an area that's covered in red, and then I marked another area that's covered in green. You're gonna utilize these two areas to eventually get the area that I shaded in black. Let's see if we can figure this out together. So these are the types of applied questions you're gonna find with the 68, 95, 99.7 rule.
I have a question.
Mm-hmm.
So from 47, which is our mean, right?
Mm-hmm.
To 56, that will be 99.7, right?
So not just 56, but between 38 and 56, that entire area would be 99.7% of the area. Yes.
Okay, thank you.
Right, so that's a good observation, Alexis, right? Because the red area I'm pointing out is only half of 99.7%, right?
So, yeah, so say my question is, it asks what percentage of widget lies above, let's say 38. So what would that be, 99.7? Because it's
No, it won't be, right? Because 99.7 is between 38 and 56.
But the question is asking above 38.
Correct.
So from 38 to 56?
Well, between 38 and 56 is 99.7, but as you pointed out, that is not what it's asking. So you're gonna have to do something else.
Yeah, that I don't know how to do.
Okay. That's the question I wanted to do together as a class. But think about it. So you know up to 99.7, right?
Yeah.
So there are 2 areas remaining at each tail, correct?
Correct.
Can you calculate that area?
You mean the two tiny areas at the end?
Yes. Yes. Can you
Okay.
calculate that area?
Yes, let me, wait.
Absolutely. You can. And that's how you're going to figure that out.
Okay, that drawing, yeah, helped me figure it out.
Because, guys, the entire area under the curve is what?
100%.
100%. Excellent. So you have all the information and all the tools you need to calculate any area. You just have to use all that information. Okay, so who can provide a solution to Christina's problem? And then we'll move on to the problem Alexis is asking, which is basically the third question in question 7 that all of you guys will have to answer as well, but just with different numbers. So we'll start with Christina's question that's in the chat. Mean of 47, standard deviation of 3, and then we're going to find the area between 53 and 56. Oh, I should actually calculate it, huh? Okay, Naja, so that's going to be similar to Alexis's question, so we'll do that in a second. We're going to focus on Christina's question for now. Yes, I expect a lot of you guys to get C wrong, because it's the most challenging one, I think, so far of this empirical rule question. But who has a solution for Christina's question?
I do. I did half of 99.7 minus half of 95. Yeah.
That's what I did too. Excellent. You got that? Good. Right, so if you think about it, actually is just a very it's a very similar kind of question of all the ones we're doing. It's just kind of thinking in different ways to manipulate the 68, 95, 99.7 rule. Okay, good. So now let's go to question C, which is going to be a permutation of Alexis' question that she's been asking. Okay, guys? So I'll share my screen because that's the number I have. All right, so what it's saying is that what percentage of the widget lies above 36? Let's see where which one is this? 36, here we go, okay. 36, and I don't know if it's gonna show, but I'm gonna exaggerate the color. So, in my particular graph, it's gonna be this green area. So there's that long line right there, and everything above that is what I'm looking at, including that red area. It's just red is like pretty dark, so you can't see the green. But from this line and all the way above. Okay, so what I'm gonna tell you is, where the two lines are in my graph, what percentage of the area is covered in those two lines, guys?
99.7.
Excellent, 99.7. So that leaves me, even though it's kind of like very big looking in the graph, that leaves me with the two tail ends that I'm showing as these arrows. That is those two areas at the tail end, these two. Outside of 99.7%, what area is that? This and this, or like, oh God.
The total is 100%, right?
Correct, exactly. So
the remaining would be 0.3.
Exactly. So the two tail ends, guys, is 0.3 in total. And we only need half of that, which is 0.15. So the total area above 36, according to my numbers, it's 99.7 plus 0.15.
Oh.
Yes, I love that sound. It's my favorite.
Oh, I got it right, yay!
Okay, Naja, are you, did you follow that? Do you want to share your screen and we can use your numbers, or?
Can you repeat how you got that?
Sorry?
Can you repeat what you just said?
Okay, so what I said was, and I'm sure it's like a similar question. If you look at my graph on the camera, it's pretty shabby way of doing this, but whatever. Between the two green lines that's on my graph here, if I can point them out, that's 99.7% of the area because it's 3 standard deviations away. It's hard to kind of tell, but just trust me on that. It's 3 standard deviations from the mean, so it's 99.7. So then the tail ends are left, the tail ends, right? That is 1 minus, or 100% minus 99.7%, which is 0.3%. But we only want one tail of that 0.3% area. So I split that by half, and that half is added to 99.7%. So anything above 36, which is this one right here, all the way to infinity, basically, all the way is going to be 99.7 plus 0.15, which is what, guys? 99.7 plus 0.15. So we have 99.85% as the answer for that question, or at least I do. Okay, so I guess that took a while. Okay, you're getting the wrong answer. Okay, so either Naja or Apurva, if you want me to solve it with your numbers, go ahead and share your screen. I'm gonna type in 99.85 and submit questions. Oh, I think that's 52. Okay, here you go. Okay, so Naja, I think we are seeing yours. Okay, so stop right there and let me just draw out what I can see. So we have mean of 38, and then your standard is 9. Oh, it's like mine. Yeah, okay, perfect. It's like this one right here. So it's gonna from 11 to 65, that's good, 97.35. Okay, what percentage of the widget weighs lie above 29? Okay, so I'm gonna use a different color. It's just like, should have a whiteboard or something. Okay, so if you can see my screen, anything above that long purple line is what I want to look at. Okay, so that's what above 29 means. And then I see, so Naja, I'll ask you this question. I have 2 big purple lines on my graph. Let's see if I can, yeah. What percentage is covered between those 2 purple lines? What percentage of the area?
68. Right?
Oh, did I not draw that correctly? Sorry, 20. Oh, 68. Yes, you're right. Oh my, sorry, that was my bad. I actually draw it on the wrong area. 68, yes. So between 29 and 47 is 68%. You got that?
Yes.
Okay, so now, oh God, this just like drew it too many times. Okay, so that's between, I don't know if this is going to make sense anymore. That's between these 2 lines, that's 68%. And then we need everything above that, okay? So let me ask you this, Naja. If between 29 and 47 is 68%, there's 2 tails on both sides that are remaining, correct?
Right.
What percentage are those 2 tails together?
99.7.
No. Okay, listen to me carefully. Between 29 and 47, as you told me, is 68%. Okay, you got that? Anything outside of that, basically, so below 29 and above 47, so the tail ends, excluding that 68%. What area is that? So these 2 tail ends.
I don't know how you get that.
So then tell me this. under the normal curve, the entire area is how much? We're always calculating out of what?
100%.
100%. Excellent. Okay, let me ask you one more time. This is the information you need to answer this question. The entire area under the curve is 100%.
Right.
And among that, between 29 and 47 is 68%.
Yes.
What is the remaining area?
You do like 100 minus 68.
Excellent.
Okay, so
Excellent. Okay, those are both of those tails remaining. But if you look at 47 and above, all the way till the end, that's only one tail.
Right.
Correct?
Yeah.
So whatever you calculate, 100 minus 68, you're going to divide that by 2.
So half of 32.
Yes, is that right? 32. Yes, correct. So do you follow my logic?
Sort of, yes.
Right? So we identify the 68, and then we still have that tail end that you need the area of. Well, how do we get that? Well, we first calculate both tail areas because we know the density curve, the entire total, and then we have that. And so now you have 68 plus 32 divided by 2. Does that logically make sense? That's all you really need to know. I mean, getting the answers correct is like, that's whatever.
Yeah, sort of.
Purva, based on that explanation, do you understand your question?
Can you hear me?
Yes, I don't know what PR means. I can hear you.
Oh, you can hear me. Okay. So I'm not, I think I have the right answer, but I'm really, like, it's saying it's wrong. And I'm trying to share, can I share my screen?
Yep, you can.
Yeah.
So Jenny's having issues with question 8, 9, and 10. Those are... Why? Go into Google spreadsheet, and then you do equal norm s dist and put in the z-score number, and that will give you left tail. And then for right tail, you do 1 minus that, and the areas in between, you'll get the areas for each z-score, and you subtract a small one out of the out of the higher one. All right, a lot of people are having issues with those, 8, 9, and 10.
You have to round it to like 4 or 5 places. If you only do
There was that one thing. Yeah, try to include like 4 or 5 numbers after the decimal point. That's one thing I didn't fix. That's right. That was accidentally clicked. So your numbers are probably right. So just go ahead and write at least 4 numbers after the decimal point and then hit enter. And then you should be right. Since you guys all got like 5 trials, you should still be able to get full points. Okay, Apurva, we still don't see your screen.
I think I don't have any tries, but I get it. I think I have the wrong decimal number, but yeah,
Perfect.
got it.
So we actually ended up going quite more than the time I wanted you guys to spend on it. So go ahead and continue this practice problem and finish it. You should all be able to get 100% on it. But if you haven't finished within this time, that's the only homework you'll have. And that's it for today. And you can take, or you know what, better yet, if you don't want to continue to work on it, if you're burnt out, don't worry about it. I'll give you some time next class so we can all finish it up, okay? I should have made it so that there's no deadline, or if there's a deadline, you have plenty of time, okay?
So if we log out, we can log back in, right? to do
You
it?
should be able to, but if not, we'll figure it out during class tomorrow, next time, okay? But try to finish at least the question you were working on, so you're not mid-question.
Okay.
I don't know if you guys are like me, but that OCD me would really bother me. So just try to finish the question you're working on, and you can end it there, or you're like, I want to blaze through all the questions now and just get over with it, then go ahead and do it. But just finish the question you're having now, and then you're good to go. And if you want to remain here and ask more questions, just stay here. I do have a meeting at 2, so I'll have to have a hard stop around 50, 56, or 57. But other than that, you're free to go.
Thank you.
Have a good day.
Okay, see you.
Thank you.
Hey, guys.
Thank
So we
you.
can save and exit the assignment, right?
Yeah, you can just exit. I don't know if there's a save button, but if there's a save button, press save, but everything should have been saved.
Okay, because I just see that it says done. So I guess you would click that, right?
Yeah, go ahead and click that.
Okay.
Yeah. If it like gives you a problem Wednesday, I'll figure it out. We'll figure it out, and don't worry.
Okay, thank you.
Yep. James Lynn, do you have a question?
I don't have any question.
Oh, okay. All right, so I'm going to stop the recording and end the meeting, okay?